Hi guys, and welcome back to Chemistry 1032 Lab instructional videos. I am your host, Dr. Russell Betts, and in this video we will be focusing on significant figures, how to determine how many significant figures you have in a measurement, and basically just how to look at measured numbers. Now, here we have one of the figures or tables, if you will, from the lab manual, and we have a series of measurements and some descriptions on what's significant and what is not. Now, let's just simply go through the rules one by one. Rule number one is if you have a measurement and all of the numbers in that measurement are not zero, that is considered to be, every number is considered to be significant. So in this number, 1.25 grams, that is 3 significant figures because all 3 numbers are measured. There is no zero digit, so therefore all those digits are considered to be significant, or in other words, 3 significant figures. Now, that's pretty simple. Whenever a number is not zero, it's significant. It's when we start adding zeros that there's some, you have to be careful, you have to look at things more closely. So now we're at this example. Zeros at the end of a decimal are significant. So what we're talking about is that zero right there that I've underlined. That zero is significant. Now, how I'd know that is, first of all, I know the rules. The zero at the end of a decimal number are significant. But here's one way you might want to start thinking about it. If you look at this decimal point right there, you'll see that there, in front of that decimal point, there's a non-zero digit. This is number 1. What I tell students to do is say, okay, if the digit in front of the decimal point is not 0, that means that this digit, the 1, and every other digit is significant. Okay, so let's see that again. That means the 1 and every digit after the 1 is significant, including the 0. Okay, but as long as this digit here is above 0, 1 through whatever number you want, as long as it's not 0. Okay, so this is 4 significant figures where that 0 is significant. Now, we're here now. The next example, zeros in between non-zero digits are significant. Now, take a look at this measurement here. We have 1.005 grams. These zeros inside of here are known as sandwich zeros. What that means is that they're sandwiched between 2 non-zero digits. The 1 being non-zero and the 5 being non-zero. The zeros in between them are significant. They would have had to have been measured. So this is also 4 significant figures. So far so good, right? Now, we're talking about this rule now. Zeros at the beginning of a decimal number or zeros used as placeholders are not significant. This is where a lot of students get a little confused, and it's really not all that hard. So let's just take a close look at this. Let's look at this example right here. 0.250 grams. So now, we have to be careful. We have a decimal number and we have a 0 right there. That 0 is in front of the decimal point. And there's no other numbers associated with that. That is simply 0. So that means that the 0 here, this one here, is not significant. It's just a placeholder. But now every number after the decimal point and after the first real number is significant. So the 2, the 5, and the 0 are significant. So that's 3 significant figures. Now let's come down here and let's do a few more examples. What if I had 0.010 grams? That's actually 2 significant figures. Now this 0 is a placeholder. That 0 is also a placeholder. They're just telling me that the number is small. But now after the first non-zero digit, that 0 right there becomes significant. Okay? This 0 and that 0 are placeholders, non-significant. After the first non-zero digit, the 1, everything after the 1 becomes significant. So after the decimal point, after the first non-zero digit, everybody after that is significant. In other words, what if we had 0.0002010 meters or something, some unit. Now, let's be careful. These zeros right here are placeholder zeros. Look right here, in front of the decimal point, it's 0. So that means that every 0 leading up to the first non-zero digit is a placeholder, not significant. The 2, however, must be significant. This is a sandwich 0, and that 0 is also significant because it's at the end of a decimal number. Again, after the decimal point, after the first non-zero number, everybody after that becomes significant. So that's 4 significant figures. All right? Now, let's look at the next example. The next example is talking about zeros at the end of a measurement that are just telling us that the magnitude of the number is large. So let's look at this example right here, 120. Now notice there's no decimal at the end of the number, it's just 120. So this number is actually 3. Oh, excuse me, it's not 3, it's only 2. Pardon me. Is 2 significant figures. The 0 is not considered significant. It is simply considered to be a placeholder. Let's take another look. What if we had 3:01:00 seconds? Well, now, in this case, the 3 is significant because it's not 0. The 1 is also significant because it's not 0. This 0 right here is a sandwich 0, so it's significant. But these two zeros right here are not. They are placeholders. They're telling me the number is large. So this one is 3 significant figures. Let's do another example. What about 401,200 miles? All right. Well, here we have a non-zero digit, a non-zero digit, and a non-zero digit. So those 3 are definitely significant. These zeros, however, are not. They're placeholders. They're telling me the size of the number. They're telling me the number is quite large. They're there to tell me magnitude. They're not measured. So this is 3 significant figures. Okay? Now, again, it's very simple. Just any 0 here, these zeros right here, are not significant because they're telling me the magnitude of the number. They're telling me the number is large. Okay? But they're not necessarily measured, so they're not significant. All right, very good. Let's clean this up a little bit. And let's move on to the last example. There we go. All numbers in scientific notation are significant. Now, when we say all numbers are significant, we're referring to the coefficient numbers right here, 1.25. The 10 and the -3 are not part of the measurement. They're just telling us that we would divide this number by 1 over 1,000. That's all it's telling us. So they're not part of the measurement. They're just there to make the number scientific, if you will. So this is 3 significant figures. What if I had, for example, 2.00 times 10 to the -4 seconds? Well, that's again 3 significant figures. Every digit in the coefficient is significant. Let's do another example. 3.0120 times 10 to the 15 atoms. That is 1, 2, 3, 4, 5 significant figures, because remember, every digit in the coefficient of a scientific number is significant. And right here, this is the coefficient of that number. So it's 5 digits, 5 significant figures. So there you have it. There's a little review of how to do significant figures and how to count significant figures. Don't just take the lesson and think that you understand this stuff. You really need to practice it and apply it. And the more you apply these rules, the more they become second nature to you. The faster you'll get at it, and the more you won't even have to worry about it during exams or quizzes, because you'll just, by instinct, use them. It's important that you get this stuff straight, and it's important that you understand it moving forward in this class. So with that, I would like to wish you good luck and good chemistry.